Hey everybody, this is Art. I'm N0EX and welcome to my YouTube channel on radio direction finding. RDF fun is what I call it. So I've got some videos out there on various aspects of direction finding and equipment and reviews. And today I'm going to go over a presentation that I gave a couple months ago at the Minnesota ARRL convention. So I gave this presentation on radio direction finding, transmitter hunting. So essentially an introduction to radio direction finding equipment and techniques used by amateur radio operators. So I'll go through this and talk about my slides. And at the actual presentation, I did a couple of demos. I won't be doing those demos today on this recording, but some of my other YouTube videos and other people's YouTube videos, you can find the information that you need that would be equivalent to those demos. So let's get started. Whoops, wrong button. How's that? Okay, here's the topics we're going to cover. What is fox hunting? Why I want to do it? We're going to talk about the different types of hunt, equipment, and techniques. I'm going to talk a little bit about maps and bearings. And then what to do when you're the fox. Things to remember when you hide and how the fox operates. And we're going to kind of get general again and talk about what you need to get started. If you're brand new, I'm going to give you some lists of things you need to get started and some tips and hints. So that's basically it. So what, why, who? What's fox hunting? Fox hunting, transmitter hunting, radio direction finding, and RDF all refer to the attempt of tracking and finding the location of a hidden transmitter. So it can be performed for many reasons. Stuck down a stuck transmitter, find RF noise sources, find malicious operators, maybe save lives, or typically more often just for fun and practice. A special note here, as this is a receive-only activity, anyone, even the unlicensed, can participate. So if you've got friends and neighbors that aren't ham radio operators, they can still come along and participate in finding the transmitter. All right, what types of hunts are there? Out in the western states, transmitter hunts can cover hundreds of miles. They'll put a transmitter up in the mountains, and it might be a day long, afternoon long, or a day long try to find that transmitter. Around here in the Midwest, our hunts are typically going to be citywide or countywide, probably initially by vehicle, and then possibly when you get to that park or that place, there might be a lower power transmitter to find on foot. And also many hunts are just held on foot in local parks with 1, 2, or 3 transmitters to find. ARDF specifically refers to a competitive international sport of searching for multiple transmitters in a large park. So ARDF, think of that as a combination of orienteering and direction finding. So it kind of nowadays more specifically refers to that competition. Hunts can be time-based, first to find is a winner, or mileage-based, lowest miles traveled is winner, or just for fun. But a note, if you're doing timed events by vehicle, you probably want to be careful with that. All right, let's talk about the easiest, simplest type of technique, and it's the body fade. So body fade can be performed with just your body and a handheld receiver. So the technique is to hold the handheld in close to the front of your body and turn in a slow circle to find the direction of the weakest signal strength. So you're actually using your body as kind of a blocker. So if you find the weakest signal strength, you rotate and find the weakest signal strength, then the transmitter is behind you. So it works. It is not the most efficient technique. So you can remember this. You might end up using it, but let's talk about more efficient techniques. So most of the time, you're going to do direction finding with directional antennas, a beam antenna. The beam will provide you with both signal gain and directivity. You would be typically moving your antenna to find the highest signal strength. You can also, if you're close to the transmitter, you can use the null. You can reverse it and find the weakest signal strength. If you use a beam on a moving vehicle, you need a way to turn the antenna from inside the vehicle. So a lot of users are going to, on a vehicle, you're going to have maybe a 3 or 4 element Yagi or a quad on a short mast, maybe out through a sunroof or out a window. The problem with beams is they're often going to provide too much signal strength when you're close to the transmitter. So you may need to use it with some kind of an attenuator. So we'll talk about that later, attenuators. Let's talk about the tape measure beam. So for on-foot use, or if you're maybe in a car but you don't have an antenna mounted, you might want to pop out of the car and get to a nice location and use your tape measure beam. It goes in and out of your car, quickly and easily because those elements will just fold up. It's lightweight, it's easy to build, it provides some gain, and if built correctly, an excellent front to back ratio. So build instructions can be found all over on the web. Here's an example. This is from the WB2HOL web page. I think he's the one who came up with the tape measure beam. Okay, so what are some other techniques we can use to find the transmitter, especially like when we're close? So when you're getting overloaded with signal, which is often going to happen when you're real close, you can try to tune your receiver to 5 or 10 kilohertz off frequency. You can use the null of your antenna that I mentioned, or you can also tune to the third harmonic of the transmitter. So for example, if you're hunting on 2 meters and 146.58, the third harmonic is going to be on 439.74. So you would tune your radio to 439.74 and then try and find the Fox using a beam width that way. The problem with your typical 2-meter beam is you might not know really what its pattern's going to look like at 70 centimeters. It's going to look different, probably not what you expect. Some people use an Elk or Arrow satellite antenna that has both 2-meter and 440 elements to hunt, and that's going to work real well for hunting the third harmonic. So again, just to make note here, most of this presentation I'm talking about direction finding 2-meter transmitter hunts. There are some held at 80 meters, 80 meter frequency. Some people run them at 70 centimeters, but I think most fox hunts, and certainly the most hunts in this Midwest area, are going to be on 2 meters. All right, let's talk about the step attenuator. The step attenuator is used to reduce the signal strength getting to the receiver to allow more headroom for direction finding. The problem you get when you get really close and you get overloaded, anywhere you point that beam, it's going to be at max level. So you need some way to attenuate the signal so you can swing the beam and actually see some movement on your received signal strength meter. So the step attenuator is going to have several shielded sections and with resistors, so you can turn on and off sections, adjust the level of your attenuation. Now, very strong RF signals may still penetrate the case of the receiver or attenuators, making direction finding difficult, but these can work, these can help you. They can also be a bit bulky for portable use, but they're certainly fine for a mobile. Here's an example of a step attenuator. You see, you can dial in, 5, 10, 20, 60, 80 dB. And a good attenuator is going to look like this on the inside. They're going to be all shielded individually. All right, let's talk about the active or offset or mixing attenuator. This is a really great way to reduce the signal strength getting to your receiver and allow you more headroom for that direction finding. You can get over 80 dB of attenuation using a mixing attenuator. And what it really is it's a mixing oscillator. And it will offset, mix in like maybe 4 megahertz with your receive signal. So you retune your radio to plus or minus 4 megahertz if that's your oscillator frequency. So if you were on 146.58, you'd maybe tune up to 150.58. And now you're not going to get into your radio, you're not going to get hardly anything from 146 megahertz because you're tuned to 150, but you're going to get a level, a new level that you can control with an adjustment on this mixing attenuator, and you can adjust the level getting to your receiver. So these work very well. They're lightweight, they're small, they're low cost. You can build them yourself. These are a couple of examples from offset attenuators from Third Planet Solar, KC9ON. The first one I think is a kit you can build up, and maybe the other one you can build up too. But these work very well. I have the one here shown on the right. I've used it, I've tested it. And it's a great way to knock the signal down so you can keep transmitter hunting when you get close. So I do have another video on this, my test of this offset attenuator, that you can go to my channel RDF Fun and watch. All right. Another item for when you get close would be the RF sniffer or a field strength meter. So an RF sniffer or field strength meter can be used at the last leg of the search, where there's a high signal strength and you're often overloaded by other methods. So a lot of sniffers and your field strength meters are going to be very wide banded, and you're going to use them without a receiver. So they're essentially just looking for this closest, most powerful signal strength that they're going to give you some indication on. So typically it's going to be used within the last couple hundred yards, maybe in the last 50 yards. So since these are wideband and not signal frequency specific, they could be subject to sensing other high power transmitters in the area. They're typically going to provide you with a signal strength meter indication, or maybe a tone that varies in loudness or frequency when the received signal strength changes. Now, I have used and built sniffers that put out an audio tone that increases in frequency that changes with RF signal strength. So the more RF signal, the higher the frequency pitch. And it's really intuitive and fast. You don't have to look at a meter. You're just swinging your beam and walking towards wherever you get that highest pitch. So it's a really fast and intuitive way to cover that last 100 yards or 200 yards. So here's a couple of examples. The one on the left is a sniffer I built. It provides that audio pitch. It's got a filter in it, so it's fairly tight to the 2 meter area. And the one on the right is something I picked up off of eBay or AliExpress. And this one does have a receiver in it, and they call it an RF field analyzer. It's probably like a cheap Bofang receiver in there, but what you do get is you get this LED display of signal strength goes from like minus 120 to 0. So it's not as fast as a meter. It's not as fast as listening to a change in audio pitch, but with a slow swing of your beam and watching that display, you can get a signal strength that you can walk right up to. You don't have to add any additional attenuation to this device on the right. So it actually works pretty good. Both these devices are about $100. I've tested them. I've got videos on both on my channel. All right, let's look at a different piece of equipment. This is called the time difference of arrival. It looks at the time difference or phase difference that the signal gets to 2 antennas. So upper right hand corner is somebody swinging this, looks like a big H. It's got 2 antennas, and what the device is doing is it's going to show you if your antennas are equidistant from the transmitter. So that's going to tell you that your transmitter, if this is your antennas, you're going to control your transmitters that way or this way. Now, better TDOA devices with a little more smarts in them and maybe some more LEDs are going to show you which way the transmitter is. So you'll always be able to tell if it's behind you or in front of you and which way to turn the antenna to get there. So you want, if you buy a TDOA unit, you want a unit that gets rid of that 180 degree ambiguity. Now, you can use these portable as shown here, or you can use them in a vehicle with a small antenna array sticking out a window or sticking out of your sunroof. You can even use this one in a vehicle with 2 mag mount antennas. You're essentially turning your car to try and get an indication to try and line up on it. So you'll know if it's mainly off your left or right, and by maybe when you go around a corner, you'll get a good bearing. So it's it works. It's an easy way to DF by yourself if you don't have anybody in your vehicle with you to turn that antenna. So down in the lower right-hand corner is the NZ1J RDF. Now you can get this kit from NZ1J. He's got a YouTube channel and a video on a demonstration of this. It works very well. I've also tested this. The nice thing about TDOAs is they're not typically sensitive to your signal overload. You don't need an attenuator. You don't necessarily need a sniffer because you'll probably be able to walk right up to that transmitter. These again are fairly low cost. The NZ1J RDF kit, if you get it from him, is about $30 for the board and the parts. This is my version of it that I built here, shown on the left, and I also worked with NZ1J and got his permission to repackage his design. So I've repackaged his schematic and his parts into a smaller package with connectors on it, so you can connect up this small RDF box in a vehicle, or take it out of the vehicle and put it on a different antenna array for portable use. So you can send me an email on that. Go to my QRZ page. I've got information on that and a video, so you can go ahead and watch that if you're interested. All right, other equipment, Dopplers. Dopplers simulate a rotating antenna, which uses the Doppler effect and some internal processing to determine the direction of the transmitter. Most are going to use 4 mag mount ground plane antennas on the roof of your vehicle. And inside there'll be a display giving you showing the relative direction to the transmitter. So this requires no actual mechanical turning of the antenna. The antennas are switched. So sometimes you're not going to have a good signal. You're going to get reflections. So the thing about Doppler is you got to learn to interpret that spinning LED or where that LED is pointing. If it's not getting a good signal, it's going to look pretty funny. Practice with a Doppler. Practice with all of any technique or any piece of equipment. It's really how you learn to read it. You're going to get some experience using it. You're going to learn something every time. Doppler is also, like the TDOA, not subject to high signal strength issues, so you won't need attenuation with that. All right, the problem with Dopplers is they can be expensive and they're not feasible for on-put or for portable use. Here is a couple of pictures of a Doppler I have. This is an older Doppler called the Agrello DF Jr. On the left is the small indicator display that's inside the vehicle that gives a relative indication. So you see that LED on is the center and the 135 is on, so this is indicating that the transmitter is kind of behind me and to the right. And the picture on the right is the 4 antennas on top of the vehicle. The Agrello is no longer available. The only Doppler I found that seems to be available, like a reasonable cost, made by hams for hams, is made by PA8W. So he's got, I think you can go to his QRZ page. He's also got a web page out there. You can contact him. He's got several models. Some are kits, some are totally completed. I think he sells an antenna array. Here's a couple pictures of what he's got. So you can go there for more information. All right. There's a couple more specialized items. One's is the Kraken SDR. This is a software-defined, coherent 5 SDR radio-based receiver. So they do a lot of processing. They've got 5 receivers tied together, 5 different antennas. They do a lot of processing. It runs on a Raspberry Pi. I've seen plenty of videos out here. I haven't tried this. I haven't seen one in operation. I've watched some videos. It's pretty cool. You can tie it to an Android app that shows you a map of where you are and an estimated location of the transmitter. It will constantly adjust as you continue to drive. It's pretty cool. It's pricey, about $600, I think, at least the last time I looked it up. And you're probably going to need to be somewhat Linux OS competent to do the setup of this. So plenty of information out there to go, do some additional research if you're interested in that. The other item that's really the Cadillac of sniffers is the VK3YNG Mark IV ARDF sniffer. So there's a website here. You can go check that out. Probably anybody who is seriously doing ARDF or that orienteering type of ARDF competition where they set up multiple transmitters in a big park, they're probably going to be using this device. You can set the frequency on it. It's going to give you that tone that I talked about earlier, that higher frequency as you get more signal. It's about $300. I'm not sure if they're still made. You may be able to get them. You can probably get them on the used market. All right. Moving on to something different. I've covered most of the equipment and techniques. Now we're going to talk about some other items. First of all, what if you're the Fox? So what happens on a Foxconn? How does the transmitter stuff work? So again, as I talked about earlier, fox hunts come in many different types, each with its own modified set of rules. So you're typically, if you're going to set up a hunt, you're going to tell the people if there's going to be a certain start time, where the start location is. You might define boundaries like within this city or within this county. It's often helpful to tell them what the antenna polarization is going to be, whatever rules you want to set up. So the Fox, the transmitter essentially can be you in your parked vehicle, sitting in a parking lot, talking them in. Or you can use a transmitter tied to a little timing controller, which I'll show you later. Or you can have a totally standalone programmable transmitter module. Those are going to be lower power. You're going to use those mainly in parks. So a lot of things out here to help you. There's small controllers that are available to transmit on a time schedule. Of course, ID the transmissions, and some can be remotely controlled by your DTMF codes on your other transmitter. So typically, what you're going to have is you're going to have transmissions on for 30 to 60 seconds and a similar amount of off time. So you might want your duty cycle of your transmitter to be 50% or 25% or somewhere in there. And that might also vary if you have multiple transmitters transmitting on the same frequency. All right. Whenever you set this up, please select your transmit frequency with care, so don't end up on a repeater input, and you don't want to end up on 146.52. You want to be off on a different simplex frequency. If you're hiding a transmitter in a public area, like maybe you put your handheld with a controller in a ammo box or some kind of can, include a note on the transmitter with what it is and contact information. We don't want anybody calling the police and thinking it's something nasty. So here's an example of that. This is a ammo can that I modified, LiPo battery, handheld, and a simple controller. It all fits in there, and it can be locked to a tree or to some kind of a post so it doesn't end up walking away. All right. What about the Fox? Here's some options for a controller. So we have the Bionics MicroFox. This is a transmitter and a controller. You can hook up to USB, and you can program this with duty cycle information, your call sign, and it's going to transmit that out. It's low power, 15 milliwatts. They have one now similar to this. It's adjustable. It'll go up to about 50 milliwatts. So very good if you're in a park or a small area like that. If you have a Bofang, you can buy this card in the middle. It essentially will tie right to the back of your, I think maybe UV3 or UV5, and you can control that and program that up. That works pretty good. You can buy this PicCon hidden controller, and essentially you create your own cable. You can tie that to any receiver. Build your own cable. Obviously, you're making a mic connection and feeding audio back to this, and you can program this up for different duty cycles and your call sign. So there's a bunch of options. Or if you want, you can sit in your car and transmit manually by yourself. That works too. So a lot of options if you're the Fox. So some recommendations when you're the Fox. What if you're the Fox and you have a starting point? When you start that, you want to make sure that everybody at the starting point is able to copy you. So run a test before the hunt. They can't hunt you if they don't have any signal to get started on. So make sure they have signal at the start of the hunt where they're going to be. Okay. Otherwise, they're going to be very frustrated. So transmit enough. Now, you're going to want, again, to transmit maybe about every half minute or every minute, maybe every couple of minutes. If you transmit more, a higher duty cycle, it's going to give them more chance to find you sooner. So if you want to speed up the hunt, if you want to make it easier, transmit at a higher duty cycle. If you want to make it harder, you can transmit a little bit lower duty cycle, but really the object is to make the hunt fun and for them to find you. So by not transmitting, it's not really making it fair. You need to transmit for them to be able to find you. So if you want, you can give clues over the air. So maybe especially to if most of the hunters have found their way, you can give some clues and help the other hunters find their way. Avoid interference. I don't mean radio interference. I mean interference with the public. So try and select your area of where your start point is and where your hiding point is to not be in the way, maybe not attract too much attention. So it would be better if the police are not called during the fox hunt. Believe me, I've been on a couple where the police were called. So you'll want to just put some thought into where you're hiding it and where your hunters are. You need to stay away from private property. Know that, if you're maybe in a big public parking lot, maybe like a parking lot of a big shopping center, it's not necessarily public property. If you're not attracting too much attention, maybe you're going to be okay, but that parking lot is owned by whoever owns that big shopping center. So they may not love what's going on out there. Also, consider hunter safety. Don't place the fox in, underneath a bridge over a moving river. Don't place it in the median between, a 4-lane highway. So put some thought into safety here and keeping everybody safe and not having the police be called. All right. Also, as I mentioned before, don't make it too hard, especially if your hunt includes some less experienced people. Really, what you're trying to do is you're trying to make it fun. You're trying to get people to find the transmitter, have experience at this. What your goal really is successful hunters having fun. I've seen way too many hunters give up because it was too hard. I've seen way too many fox hunters give up, when they're inexperienced because they get close and there's way too much signal and just many reasons. So think about that. All right, I'm going to talk a little bit about maps and bearings. Depending on the type of hunt, you may find it advantageous to use a map. So obviously it's going to be more helpful for hunts covering a large county-wide area, but you're probably not going to need a map if you just hunt in a small park. So we've probably all done this. Locate yourself on the map, use your equipment to get a good bearing, draw that bearing from where you are on the map out in that direction. 2 bearings may give you an intersection, but you're likely going to need several bearings as you move to get an idea of the likely transmitter locations. So, and if you are drawing a bunch of bearings on the map, you're going to get a couple bearings that really don't seem to match or correlate to the others. Just ignore those. So, for example, theoretically, if we're out there driving around on a vehicle and we pick up a bearing, maybe we got a bearing here, it's to the southeast, and we're in a vehicle, we're traveling along. I'm going to draw that on the map. And then we're going to travel some more, I'm going to get another bearing, I'm going to draw that on the map. Then we're going to try and get a little closer, and we're going to try that bearing. Look, they all meet right down there. It looks like a park. And is that realistic? It's not realistic. It's not realistic because your bearings really aren't going to be that accurate. If you're using a beam, every beam has a beam width. A short beam is going to maybe have a 60-degree beam width. So you're going to be lucky to get within 30 degrees when you take that measurement. If you're working a Doppler, you might have a LED display, but it's not going to be accurate to that exact number. My Doppler was a circle of 16 circles, so it's really plus or minus 22 degrees. So what you're going to do is you're going to draw some bearings and you're just going to try and get yourself closer. This is a little bit more realistic, showing you that, that variation that it could be. You can draw your bearings like this and know that they're not all going to cross in the same point. You're going to, maybe get to narrow down the area. All right. Here's a quick slide of a hunt I was on recently. I kept track of these bearings. I took the first bearing I got. I went to the east. I parked at a park, and I got there, and there was no signal. So then I moved back to the west. I got another bearing that's south. I drove along the road farther. I got another bearing that's south. So this is my fifth bearing. So it took me 5 bearings to essentially determine that the transmitter is, either in this regional park or close to it. So this is more reality. The bearings are still helpful, but don't get in your mind that they're going to all cross at a certain point. All right. There are some mapping apps. If you have your phone or an iPad, there are some apps available that can help you plot your location. Assuming you got GPS, it'll allow you to enter bearings, and it's going to plot the bearing lines. So I haven't used any of these. I've just played with a couple of these. I haven't used any of these on a hunt. SigTrax seems to be the app that's most used from what I've found out. Fox Hunt Pro is out there. CalTopo I've seen used. Map and Compass appears to be older and unsupported. I'm not sure on that. So, if you've used these, comment. Let me know. Let me know which one you like, which ones of these work well. I can't comment. I'm really only commenting that these are out there and they may be helpful for you. All right. Now we're going to talk about what you need to get started. So if you're portable, if you're doing on-foot hunts, maybe in a park or where there's likely only a short drive, you can start with the following. A handheld receiver, obviously. Could be a scanner, could be your handheld transceiver. Tape measure beam antenna is great. You can build it yourself. They're lightweight, they're portable. You can shove it in and out of a car. And you need an attenuator RF sniffer. Remember, I told you you're going to get overloaded with signal when you get close. So you need an attenuator or a sniffer. If you're going to go with an attenuator, I'd go with a mixing attenuator. Or you can go the other way. Instead of using the beam, you can go with a handheld receiver and the TDOA. Remember that device with 2 antennas? So you can use that, and then you don't need to worry about a sniffer or attenuator. All right, if you're mobile, this would be good. Have somebody on the roof turning that antenna. Well, that's probably not realistic. All right, you can start with the following. You can use your mobile receiver in a vehicle. You can use a handheld in there, or a scanner, whatever you want to use inside as your receiver. You can mount a short beam on your vehicle that can be safely rotated from inside. So you'll want a passenger rotating your beam if you're going to turn the beam going down the road. Just for safety, you don't want to be doing that and trying to drive at the same time. Again, if you're using a beam, you're going to need an attenuator or an RF sniffer for when you get close. Or you can use a TDOA in your vehicle and a rotatable TDOA array that somebody can turn going out the vehicle's roof. Or, as I mentioned before, you can have 2 mag mount antennas up there if you use your TDOA. It's just not quite as simple. I will say that with a TDOA or a Doppler, it's probably advantageous to have a short beam accessible in case you get to a point in your hunt or at the start of the hunt where there's kind of a low signal strength. A Doppler or a TDOA are going to knock your signal strength down by a little bit. once you get going in the right direction with a beam, you shouldn't have any problem. All right. Fox hunting hints. Practice with whatever equipment you have, so you know how to use it, you know how to hook it up, you get experience with it. I can't stress practicing so you learn how to, read what those LEDs are telling you if you got the TDOA or if you got the Doppler. And keep moving. We all know that there's reflections and there's multipath, but whether you're walking with a beam, whether you're walking with a TDOA, whether you're driving with a Doppler, if you move, it's going to average out all those reflections and all those changes. So walk or drive, keep moving, and you'll be able to tell either when you walk and swing that beam or swing that TDOA, or you drive, you can use your eyes and your ears and your mind to average out all that jumping around of the needle of the LED, and you're going to figure out a more accurate direction. All right. Just a safety reminder, don't drive a vehicle and operate RDF at the same time. You're going to see your friend in your rear view mirror if you're not careful. So we take driving distracted a lot more seriously these days. Okay, other hints. Transmitter hunting gets more difficult as you get closer and into very high signal strength. So I've mentioned this. It's worth mentioning again. I've seen so many people get fall out of fox hunting because they get frustrated when they get close and they don't know what to do. They don't know where to go. You need to have a way to knock down the signal strength when you get close. You need to have an attenuator or a sniffer. And the only way you wouldn't need that maybe is if you're in a park with a very low power transmitter, and then maybe some of the other ways like tuning off frequency or third harmonic is going to help you with that. But typically it's going to get very difficult when you get real close if you've got a lot of power. All right. Another hint I've got is carry a second handheld receiver with you when you hunt with its antenna removed. So turn this radio on, turn the volume up, turn the squelch up. And what's going to happen is when you get really, really close, when you get a lot of, really close to that transmitter, this radio with the antenna off is going to start sounding. You're going to start hearing the signal in there. And then you're going to get, and then you are really close. So you won't want to move too far away from that area. All right. Another hint, don't burn out your equipment. If you're using a TDOA or a Doppler device, make sure that if you're using a transceiver, that you disable the transmit capability on that. If you transmit into a TDOA or Doppler, there's a good chance you're gonna burn that out. You're gonna burn up some diodes or something. All right. I've covered most of the information I wanted to cover. These are some references, some places you can go for additional information. I'm going to hit these really quick. There's a homing in website. It's a ton of information, a ton of links. Some of it's a little bit older, but it's a great place to start your RDF research. There's a book, The Bible of Transmitter Hunting, is probably for amateurs anyways, is called Radio Direction Finding Simplified by Mowell and Curley. So it's a great reference. It is a little dated now, so it's 20, 30 years old. So it's still a good book. It's somewhat dated, but if you can pick up a copy for cheap, it's probably worth doing. There's a document on the web that I found that's about 17 pages. It's some great RDF tips by VE3RRD. Bionics is the place, the website that produces the products I showed you with the transmitters and the controllers. So go check out their stuff. Tape measure beam plans, search on WB2HOL, or there's a link to that so you can build your tape measure beam. Offset attenuators, go to Third Planet Solar, there's a link for that. NZ1J TDOA unit that I showed, he's got a YouTube page. Search on NZ1J, you'll find that. I've got YouTube page that I've done various equipment demos or reviews on, so go to YouTube and look up RDF Fun. And there's also some Facebook groups There's Minnesota transmitter finders. So since we're in Minnesota, I've highlighted a couple of these. There's a nationwide one here in the middle, covering amateur radio DF related stuff. And then one I've put together that highlights transmitter hunting in the Minnesota area is the third one there. So go to Facebook and search those up if you're a Facebook user. So if you're interested in follow-up questions or comments, you can email me. If you're interested in fox hunting in Minnesota, you can get in touch with me. Go to my Facebook page. I try and highlight upcoming hunts. If you have any comments on anything in the video, if you disagree with me or if you've got great ideas on other equipment and other techniques, leave a comment below and let's chat about it. Let's talk about it. Certainly love to get your input on some of this stuff. All right. When I gave the presentation, there was a prize drawing, but that's all I got. I'm going to go back to this camera, and I hope that this was gave you some knowledge and was some interest. So comment, share, like what all the YouTube people do. Thanks for sticking it out for this long presentation. Bye-bye.